The length, width, and height of a box are different integer lengths. If the volume is 125 cubic centimeters, then which of the following could be the length of the height? So, first of all, think about this. 125, of course, is 5 cubed. And so we could write it as 5 times 5 times 5, but those are three of the same numbers. How would it be possible to write this as a product of three separate, different integers? Well, we could also write it as 1 times 5 times 25. And so that would work. That's a product that equals 125. We have three different integers. And of course, we could rearrange those so any one of those could be the height. So all three of those are possible for the height. There's no way, though, that we can have 125 as one of the factors, because then we'd need to have 1 and 1. And then we'd have two of the same, so that's not going to work. So D is not going to work. Only A, B, and C work. And so those are the answers. Okay, there are a few ways to approach this. I'm going to say, let's say that's the center, and we'll say that this length is R. And so the smaller circle has a radius of R. That means that its area is pi r squared. That's the whole. That's the missing part. It also means that the larger circle has a radius of 2r. So its area would be pi times 2r squared. And of course that would be 4 pi r squared. So that's the area of the whole circle. The shaded region would be the difference between these. So 4 pi r squared minus pi r squared, well, 4 of anything minus one of those things is 3 of those things. 3 pi r squared is the shaded region. And so now what we want is the ratio of the shaded over the whole. So that is 3 pi r squared divided by 4 pi r squared. The pi's cancel, the r squares cancel, so this is why it's okay to introduce a variable, because we knew it would cancel. And we're left with just 3 over 4. That's the answer.
All right, let's begin by labeling our diagram. The question tells us that DC and AB both have length 9. So we'll add that information here. The question also tells us that DB has a length less than 3. Let's see what happens if we make this length DB exactly 3. Now to evaluate column A, we need to find the length of AC. So we'll say for the time being that this length is x. Since ABC is a right triangle, we can use the Pythagorean Theorem to write the following equation. From here we can solve for x to see that x equals 15. So we'll replace this here. This tells us that if the length of DB is exactly 3, the perimeter of triangle ABC is exactly 36. It's equal to the value in column B. However, the length of BD is not 3, it's less than 3. So we'll add that here. So if the length of BD is less than 3, that means the perimeter of triangle ABC will be less than 36. We can now see that column B must be greater than column A, so our answer is B. There are several possible approaches we could take here. Here's one of them. Since we have two intersecting lines, we know that the angles opposite each other must be equal. So here's our first equation. We'll solve this for x by subtracting 2x from both sides. And now we'll add 35 to both sides. And now we'll divide both sides by 3 to get x equals 25. Now let's take this value of x and plug it into one of our angles. Let's use this one. We'll replace x with 25 here. And when we evaluate this, we get 90 degrees. Now notice that these two angles are on a line, so they must add to be 180. If these two angles must add to 180, then we know that this angle must be 90 degrees. This is our second equation. We'll solve this for y by subtracting 24 from both sides. And now we'll divide both sides by 2 to get y equals 33. So our answer is E. All right, to begin, the question tells us that AO has the same length as OB. So we'll add that information to our diagram. Now in this question, we're comparing the area of the semicircle to the area of the triangle. Now, if the question tells us that O is the center of the circle, that means AO must be the radius of our circle. And since OB has the same length as AO, OB must also be a radius of our circle. So if we extend our circle, the tip of our triangle will just touch the edge of our circle. Now for our last step here, we need to recognize that the area of our lower semicircle is equal to the area of our upper semicircle. And since our triangle fits inside this semicircle, the semicircle must have a greater area. So column A is greater than column B, which means our answer is A. To begin, let's remove the top 3 squares to reveal the largest shaded square with area 50. Now on top of this square, we're going to place a white square with area 32. When we do this, a portion of the shaded square remains visible, and the area of this portion is 18. We'll now follow the same procedure with the next shaded square. The area of this square is 18, and on top of this square we'll place a square with area 12. When we do this, the area of the visible portion is 6. So now we're going to compare the area of the small region to the area of the large region. This ratio is equal to 6 to 18, which we can simplify to be 1 to 3. So our answer here is D.
So we're going to put on our geometry hats here for a moment. If you're not already wearing your geometry hat, go ahead and just put it on, would you? It is a quantitative comparison question asking us which side is greater, column A or column B. And column A is the circumference of a circle with a diameter of the square root of 50, and column B is the perimeter of a square with the side of the square root of 50. Now, just like on TV with police procedurals, you can do this question the easy way or the hard way. And we're going to take a look at both, but we'll start with the hard way and then save the easy way for dessert, just because it is so quick and easy. And the hard way, truth be told, isn't all that hard. So let's go ahead and just draw these shapes right here. We got a circle with a diameter of root 50 and a square with a side of root 50. There we go. And because we're going to be crunching numbers, why don't we just take the decimals of these? What is the square root of 50? If you plug that into your calculator, you get 7.07 for each of those. All right. And again, the hard way just involves knowing your formulas. And if you don't, you really should review these. These are formulas that you should have in your back pocket. The formula for the circumference of a circle is 2 pi r. So let's calculate it. 2 times pi, which is 3.14, times the radius of this circle. Well, if the diameter is 7.07, then the radius is half of that, which is about 3.54. And I'm rounding here. And so if I multiply that out, what do I get? 2 times 3.14 times 3.54 gives me 22.20. Again, with a little bit of rounding at the end. It's not going to change the answer. All right, let's take a look at column B, the perimeter of a square with a side of root 50. Well, the formula for the perimeter of a square is 4 times the side of the square, right? We have 4 sides. All of them are equal. I'm just going to add them up 4 times, and that gives me the perimeter. So it's 4 times 7.07, which is 28.28. And clearly then, I can say that column B is the greater value using my math. But I want to show you kind of this cool little slick way to do it. So let's go back to the beginning here. If I take this circle that has a diameter of root 50, and I move it into a square that has a side length of root 50, you'll notice that this value and this value are the same. That means that this circle would fit perfectly into that square. And if you don't believe me, then draw the diameter of the circle inside the square, and you'll see that it matches the side exactly. So if I do that, I can confidently say, okay, the square is going to have a larger perimeter than the circle's circumference because it goes outside. Just imagine someone walking around the edge of that square versus someone walking around the edge of that circle. The person walking around the edge of the square will have gone a larger distance. And if that doesn't make complete sense, go ahead and just watch this over a few times or know your formulas. It's not the end of the world to just do this problem formulaically. Column B, again, is the correct answer here.